Jai Jagannath dosto. So today we discuss about synchronous motor. So what is synchronous motor? The AC motor which runs at a synchronous speed we call synchronous motor. So what is synchronous? In previous video we already discussed about synchronous. Synchronous means similar, means the speed of the rotating magnetic field and the speed of the rotor are equal to each other. So the speed of the rotating magnetic field we call the synchronous speed. The rotor rotates at a synchronous because the speed of the rotating magnetic field and the speed of the rotor are equal to each other. But in the previous video we already discussed in induction motor that the speed of the rotor is always less than the speed of the rotating magnetic field. But in the synchronous motor the speed of the rotating magnetic field and the speed of the rotor equal to each other. As the speed of the rotor is equal to the speed of the rotating magnetic field, so we call this motor is a synchronous motor. This synchronous speed we can determine by the using of the number of poles and the supply frequency. This synchronous speed is determined by this formula that you can see ns is equal to 120 f by p. If you increases the frequency, then the speed automatically increases. If you decreases the number of poles in the rotor, then the speed also increases. Here is another shocking thing is that this motor is not a self-starting. For making this motor is a self-starting, we give an external DC supply to the rotor of this motor. As we give AC supply to the starter of this motor and the DC supply to the rotor of this motor, so we call this motor is a doubly excited machine. So there are basically two types of synchronous motor we use. One is silent pole type synchronous motor and second is non-silent pole type synchronous motor. So first is silent pole type synchronous motor. So in this type of synchronous motor, the rotors are known as projected type pole because the poles are projected out from the surface of the rotor core. So this motor has a non-uniform air gap between starter and rotor, because if we are not giving a non-uniform air gap between the starter and rotor, then we can't generate a pure sinusoidal wave or sinusoidal voltage as a output. So for this reason it have a non-uniform air gap between starter and rotor. If we give a uniform air gap between the starter and rotor, then it have a constant air gap between starter and rotor, due to which it have a constant reluctance at the air gap, and for which reason it can't produce or generate a perfect sinusoidal voltage. So for this reason, if we give a non-uniform air gap for which it have a changing in air gap and which produces a perfect sinusoidal voltage. So basically these motors we used where we required a low rotational speed, such as in the hydroelectric power plant to drive the generator. So these motors have a typically speed about 100 to 375 rpm. So now we discuss about non-silent pole type synchronous motor, and this non-silent pole type synchronous motor also known as the cylindrical type synchronous motor or the rotor wound synchronous motor. So this motor has cylindrical rotor with parallel slots for the rotor windings. So this rotor is made up of solid steel and has a small diameter with longer axial length than the silent pole type rotor. So the axial length depends on the size of the diameter of the rotor. In silent pole type rotor, the axial length is less due to the larger size of the diameter of the rotor. But in the non-silent pole type rotor, the axial length is very high due to the smaller size in diameter of the rotor. So these motors are used where we need high rotational speed, typically about 1500 to 3000 rpm. So this motor is more robust in construction and less noise with less losses than the silent pole type motor. So this motor we used in high rotational speed applications like in thermal power plant and nuclear power plant.